G'day guys. Have a question. What is the better detector? A GPX 4500 or a GPX 5000? Now, this GPX 4500 on the bench at the moment, this one here, that's got a gain of 48 in the input stage, and it's sitting there. You can hardly hear it. I've got it set on the back gain of 1. It's in mono mode, but it's on a cancel figure 8 coil. But I've got the electric heater. I'll just turn this right up on the audio, so you may be able to hear it. That's full on the audio, and it's quiet. It's very quiet. And what I'll do, I'll just go around here with this, and I use a small speck of gold on the coil. Like I say, it's on a gain of 1, and it's running beautifully quiet. It's factory default. I'll have a look at the settings on it. Okay, here we go. We're in deep. We're in normal mode. It's in tracking for whatever reason. Makes no difference, and it's in mono. All the rest of the settings are factory default, and it is quiet. Okay. So you get the idea that it's pretty quiet. We'll turn him off, and I'll get in here and pull that out. Pull out the coil connector, and very carefully, because it's got the mylars on it, I'll pick it up and put it over here in a box. So what we'll do now, this is a 5000. I was just having a bit of a play with this 5000 because to me it's extremely noisy. So what we'll do, we'll hook up the coil, and I have another 5000 apart from this one, and I'm going to hook that up as well. I'll just try both of these. This one I've been attempting to try and get the noise out. So anyway, we'll turn him on. Let's make sure all the settings: tracking, mono, normal, and deep. Now this is also on a gain of 1, unless it's changed. I'll have to get around here and have a look. No, it's on a gain of 1. Now, this is the interesting thing. This detector has an input gain set at 34, which is the way they come out. So it has less gain in the input stage than what the 4500 does, but it's noisy. You can tell it's noisy. I'll just get the small bit of gold again. We'll give it a test. We'll go around here. And I found this. You probably notice that it's noisy, and because of the reduced gain in the input stage, it's not as good as on that gold as what the 45 is, which stands to reason. But why is it that the 5000 is so damn noisy? It has less gain. It's in the same operational modes, and I've done a frequency sweep on this before, and it's just as noisy across the whole spectrum. I can't get rid of the noise on the 5000. Now that's weak as weak, right? It really is. That's weak compared to the 4500. So we'll go back to this one here again. Okay, I could do a frequency sweep for you. Here we go. I'll let it do its auto tune won't make any damn difference. Let it howl away. Yeah, I thought there was a bit of noise coming out of one of the power rails, so I just tacked a electrolytic capacitor onto it to see if it made any difference to the noise. It doesn't make any difference. So these things are just noisy. Let's just have a listen when it finally gets around to doing its auto tune. You'll get there eventually. And it's still chirpy, maybe a little bit less, not much. And you know, we can go on the gold again. There's no detection out here. It's really, really weak. And that is because of the front end gain for sure. If I went in on that on the 4500, it would scream like crazy. So what we'll do, I'll just turn this one off and disconnect it. So is it all 4500s? Sorry, all 4500s have got better sensitivity and quietness compared to the 5000, or is it just one 5000 that is noisy? Well, I've got a stack of detectors here which have all come in for repair, but I've also got this one, as you can see there, factory standard 5000. And if you have a look down there, if I loosen that off, I can do this. There we go, all down there. There's a few detectors down there that have I've actually repaired all those, by the way. So we got this one here, standard GPX 5000. Okay, we'll stick the coil. How's that? Because I used to do a lot of radio communications. Antenna, coil, same thing. It is an antenna, believe it or not. The coil, technically, it's an antenna. The transmit antenna and a receive antenna. Okay, we've got that in tracking. I've got that in normal, mono, normal, deep. Same as the other one. And I'll just plug the battery in there. And I'll put it in factory default because I don't know where this one is. We'll have a look. Okay. Well, there's already, for some reason, I couldn't see what I was doing there. Everything's caught up. I have to turn it around more. Try again. Okay. Helps if I do the right knob, wouldn't it? And then you do that. Of course you do. I'm working mirror image off the back of the phone. Anyway, this thing's noisy, so we'll go down through the settings. There we are, RX gain. Let's turn it down. We'll put that on 1. RX gain is on 1. And what I'll do now, I'll let it do a frequency scan. We'll see how this one comes up. But, for deep gold, if you're specifically looking for deep gold using mono mode, the 4500 has an edge over the 5000. And that would probably be true on everything except probably the hottest mineralization, something along the lines of trying to detect on a piece of corrugated iron or something. But it should handle all situations. Even the 4500 does handle all situations. Maybe it's a little bit extra um, on hot rocks and so forth. But, you know, I'd rather dig the odd deep hot rock than miss out on a big piece of gold any day. So anyway, we've got this 5000. Does it sound quieter? It's still chirpy, but you know, like I said before, the level of audio coming out does vary for some reason. Even if it's all on the same setting, some are louder than others. Never been able to really work out why. So anyway, what we'll do, we'll go around to the coil. We'll get our piece of gold. Still doesn't detect far out from the coil, but remember we're on a gain of 1. It's about the same response as the other one, and it's still chirpy. You can hear the chirp there, I take it. Oh, I probably dragged the speaker when I pulled the battery, so I'll aim the speaker over here a bit. There we go. Now you might be able to hear it. I've got the audio amplifier full. You know, probably turn the threshold up if you want. But to me, it's still a little bit chirpy. I do think the other 5000 is worse. I don't know, what do you think? You probably have to go back and listen to the different detectors through the video and see what you think. Turn it around again. I've got the speaker pointing there now, so it was buried way back next to the battery before. So there's that 5000. Let's have a look here. I'll have a look at one of these ones I've repaired. I just pick something down here. I'm trying to make sure that I grab a stock standard detector. Well, actually, I got this one here, which this one had a fault, but I fixed it. This is the one I did the video matching the op amps with a trimming resistor. We'll just see how this one goes, noise-wise. Okay. So this is a 45. Okay. Have him there. I don't know what's set where on this, so we'll have to put him in the factory default. Make sure I've got where I got the settings on this. Deep, normal, tracking, mono. Okay, that sounds very noisy because it's on full gain. Okay. Okay, whoops, wrong way. Gain on 1. And what we'll do, we'll give it a see how this goes. But I'll tell you what, these detectors, if you really start having a look inside, they do create their own noise in part of the circuit. And I'm sure that it intermodulates with the incoming signal somewhere in the electronics, because if you disconnect particular or certain little sections of the electronics, a lot of the noise goes away. And you know, I'm gonna keep tracking it out because, you know, okay, this one's probably just as chirpy as the 5000. I mean, it's got the high gain resistors in it. So yeah, it's interesting, isn't it? Maybe I've just got the other 5000s quiet. Maybe it's a, I don't know, good version or something. Try the right size. Oh, we go around here. Now, the return signal from that piece of gold, it's a lot more sensitive than any 5. See, out here with the 5, we weren't getting a signal. It's a lot louder. But this detector's more noisy in itself. Let's have a look. No, everything's the same. So just do another frequency scan and just see what's going on here, because it's very funny that when I was looking at these last night, the 5s were more noisy than 45s, especially the one I did first. So just wait for it to go through its frequency scan. You think you can run a frequency scan in the background because it's a wideband system, and you could automatically, it could auto tune to the quietest part, but it didn't make any difference. Okay, it's noisy. I'll put the 5 back on again. Maybe it's louder because I put the speaker up closer, but we'll see. So that one can go back in its box. Okay. Okay, I'll grab this 45 again. I'm trying to work around the camera. Oh, dear me. It's quite difficult. I'll turn him on. It would have retained its previous settings. That's far quieter. It's far quieter. Isn't that amazing? Okay. And go around to the coil, like so, and same bit of gold. Far more sensitive and far quieter. Now, let me think about this for a minute, because I think I'm going to have a look. I reckon I've done something this and forgotten I've done it. I'll pull that out. These plugs, after you push them in and out umpteen hundred times, they become very, very tight. Always take that out, and I'm going to disconnect the front mylar just because it can pull with the cables and things. Yeah, turn it on. Yeah. Okay. Yeah. Yes. I have done work on this detector. That's why it's so quiet. Oh dear me. Well, this goes to show. Well, you can see I have done work on it. It's one of my own ones, and I thought it was standard. No, I've actually gone and done work on it. As you can see, I've replaced all the front end switching. I've put in a new um, AD ADG 333, that chip there. I've done some bypassing in parts of the circuit, and that just goes to prove then that the new MOSFETs that I got, um, those ones there, are much better than the 2SK 1334s for sure. I also swapped out this one here. I think the other video I said it was a okay, what I said it. I said it was something anyway. An IRF 214. It's not an IRF 214. It's something else. It's oh, what are you? What are you? There's two. There can be two types in there. One's a ZVN 2420, I think it is. But even that is switching in the damping resistor on and off. That one I've changed there has a lot less capacitance, and it has greater conductivity, or should I say less on resistance. What else have I done on this? I've done some bypassing on parts of the circuit, and I have done a bit of work on the input stage on the other side actually. If I actually look, yeah, I have. I can see I've changed the input MOSFETs here as well, and I've also replaced the IRF what is it, 9630 device, and there's a reason for that. I replace that device with a better MOSFET, but yeah, you can do your own experiments and see if you can work out why I changed it. Does it have more current capability, or does it have more voltage headroom? One or the other. Or does it have less gate capacitance? Does it switch quicker? Well, there's three variables there, so I wonder which one it is. There's a reason though. See if you can work it out. I don't want to spoon feed everybody with how to do this and how to do that. I want people to get in there and learn, have a play yourself. Um, you know, I don't even know if you'd be able to pick up the number on that. Probably not. It's pretty dark here, but you could probably zoom in. You might be able to find the number and then replace yours. But there's a lot you can do on these detectors, obviously, to get the noise out of the system. Like this one here, it runs beautifully. It absolutely creams the other detectors, except my one with variable gain. It won't cream that because I can, it's also very, very low noise and I can crank up the gain. So, like I say, these old detectors, once they're done up, they can actually, in a lot of cases, beat the newer detectors. And with these detectors, you've got a good choice of coils. There's plenty of cheap coils on the market. You don't need, a fancy, coil is going to cost whatever they cost now. What, 700,000 bucks for a coil or some of the new detectors or more. Use the old ones. You can still pick them up for 100 bucks, 150, 250 bucks. And there's plenty of them out there. They work fine. Coil's a coil, There's not much difference really in the manufacturing of coils, except the shielding. But I've already mentioned that before. So yeah, we'll put this one back in its box. Damn, I only grabbed it because it had standard. It had standard written on the case there. If you can see that, STD. Doesn't mean some disease, it means standard. It's just my abbreviation for standard. So, that's that. But on that front, let's move this over here a bit. stick that there so you can look at the nice blue colour. I've got another one here. What's this one? I lose track of what detectors I've got. It's quite amazing, isn't it? So what's this one here? Oh, GPX 4500. Hey, this is a standard one as well. Well, this might be the real standard, and I swapped the cases over. God, I can't remember this one either. It's one I've done a while ago, but you know, we'll have a look. We'll have a look at this one. Just see what happens. Then I'll get intrigued if it works better, and I'll drop the case off and have a look at what's inside. Okay, just check the switches around the front. We're in deep, normal, tracking, and mono. We want to put on mono on that coil, so I'll turn him on. Okay, it sounds turbocharged. Okay. Okay, RX gain. Down to 1. Okay. I got the camera really close to the coil. I better move it away. It could be causing interference. But that sounds quite punchy for what it is. And I'll just let it do a frequency. Okay. It's screaming like that because it's got variable frequency in it. As it clocks up, it'll pump up. It won't find a quiet frequency. It needs to be manually set. But anyway, I'll see what it does. It might do. Oh, it's getting to a quiet realm now. Let's see what happens. It's getting noisy again. That's interesting. Oh, there it goes. Oh, that's heaps quieter. I'll crank this up. It's not as bad as the other ones that are noisy. Anyway, what we'll do, it's on a gain of 1. We'll try it with the gold again. It's a little less punchy than the other one, the other 4500. But it might be where it's put itself in the tuning. I'll just have a look. Because this one has got variable frequency. And if you've got variable frequency, the higher numbers will give you more sensitivity. And there you go. It's done its manual tune at 181, which is sort of mid. But I'll take it up a bit. Let's take it up. 221. See if it makes much of a difference. It's a little bit more sensitive. And remember, it's on a gain of 1. It's definitely quieter than the 5000. Any 5000 is definitely quieter. It hasn't got all that fast chirpiness to it. You have a listen to that. It's definitely better. So, horses for courses, eh? Turn him off and disconnect him. But the 45s are definitely quieter. And that modified one is definitely really quiet. So down there we go. What I'll do, I'll just get another. Have I got one? What's that? That's 45. Just see if I've got another 5 kicking around. No. There. I got 2100s everywhere, and what's that? That's 3,000. I'll tell you what I have got though. Let's have a look at this one. Remember this one here, no ears. That's got a lot of stuff done to it. Let's have a look at no ears. So 4500. Uh, Even though it's got the fairly latest type of upgrades component-wise in the detector, I've been able to get hold of even better stuff again. And yeah, this one's got variable gain. So we'll turn that down, turn it there, and if I remember rightly, about halfway equals very close to standard Minelab gain. On a standard detector, there's not much difference. Anyway, turn him around. We'll put him in factory default and see how it goes. Okay. Backlight. Go for the settings, make sure everything is about right. RX gain is 9. Let's turn it down to 1. Now this is a modified detector, of course. Whoops. Now I'm just swinging the coil. I kicked it with my leg, so I moved the tripod. That's very, very quiet. That's extremely quiet. I've definitely got all the front switches in the right spot. Let's have a look. Oh, helps if I turn the camera around. Let's have a look here, right? So I've got the gain roughly about halfway on the front end gain. It's got front end gain. It also has variable frequency. I haven't done a frequency scan. It's sitting at 128 where the Minelabs usually run. That might be a little bit low frequency for that size gold, but we'll have a look. Definitely very, very quiet and is picking up round about the same as what the 5000 does without all the squawking noise. So definitely, I know this one works really well. There's a lot more gain I can get out of it as well. I'm not going to get the front end gain out. What I'm going to do on the back here, yeah, I'm going to take the frequency up because it's on low. Take it up to about 180. I'm pretty sure it's got variable gain in it. Variable frequency, sorry. Actually, I'll just do an auto scan. I'm not sure if it has or it hasn't. Let's have a look. No, it must have. But anyway, let us do its screaming bizzo. Sounds like a kettle. Because it's scanning the frequency so fast, and because of the variable gain, it does move the frequency far greater per division, and thus it pumps up the integrators and makes noise. But anyway, oh, that's so quiet. I don't know where to put it frequency-wise, but we'll have a look. It's quite sensitive, even though the audio is not that punchy. But we'll have a look where we've gone. Yeah, it's put it down the low end again, 117, I think. I'll just wiggle that and make it light up like a Christmas tree. 118, 117. Yeah, so that is where it has ended up. So, okay, we'll leave it there. That is for larger gold or more reactive soils, the lower frequencies. So let's actually use the front end gain on this and turn it up. So that's about 3/4, and I can hear interference. It's repetitive, so hang on a sec. I moved this from where it wanted to be on 117. I moved it to 118. Let's put it back to 117. There you go. I put it back on 117, where it wanted to be. So obviously, even with the variable frequency installed in these detectors, the automatic frequency selection inside the detector is still working quite okay. I didn't think it would do, but it obviously does. I only had to move it one notch and got away from that interference. Anyway, let's have a look here. Even at that low frequency, we're absolutely creaming it on that 0.1. Far greater out here. I think I did a video where it's on a standard detector, and I was actually level with this, with the end piece here. So I'll see how that goes. Very nice. Let's crank the gain up some more on the front end. See, this should have brought up a lot of noise, but it hasn't. So it just shows you that the front end gain is far more quieter than the back end gain on these detectors for chirpiness. So there's something going on in the way wait for it to behave itself. There's something going on in some sort of mixing or something happening in these detectors when you crank up the back gain. But anyway, we've got a little bit of chirp coming through. Yeah, it's got a little bit, but anyway, we'll see what happens. So you can pick up here somewhere, but we'll go back to here and let's do a manual frequency. Okay, we'll put it back on. Oh, it doesn't make any difference. Put it up on 200. Very, very. Oh, that's right. With a cancel coil like this, I keep forgetting about. We get some funny phases, and if we have the gain up too far, it'll desensitize the front end. So I'll just turn the gain back a bit because we're up near full. That'll probably do us there. A bit more. So about 3/4. Yeah, I don't know if it made that much difference overall. Much of a muchness. But like I say, we got the back gain on one, so it's going to take a lot of input signal to actually drive the rest of the detector. But even so, that's very, very quiet. And yeah, it's making sure I have got the controls in the right spot. But that is so far less chirpy than the 5000. That's really, really quiet. You know, the audio's flat out. Listen to that. It's hardly anything. It's really quiet. That's how detectors should be. If you can keep a detector this quiet, you're not going to miss anything, because any difference is going to really stand out. If it's sitting there going chirp, 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 like a little birdie in your ear, you get mentally desensitized two signals, your brain will actually turn off. It just says, oh God, what's this horrible noise just keeps coming in, and you won't listen to it. You mentally won't listen to it, even though you're hearing it, but you're not going to take any notice of it. So let's go back to this, oops, go back if I can get it. Gotta reach over the tripod and that. So go back to this 5,000 again. And okay, without ripping anything, I don't want to rip anything off. So on we go. It should have retained its settings from before. Yeah, hear that chirpiness? We're on zero gain, or gain of 1. Exactly the same as what we had before on the 45s. Same bit. See, out here, I'll touch on this like I was touching before. There's definitely less signal there. I'm going right in the middle of the coil. So if you can hear that, you can hear that chirpy bizzo. You know, there's something going on. I'm going to find out what it is. There is definitely a difference between the 5,000 and the 45, and you know, if the noise is coming out the front end, it should be less because the 5,000 has less gain. So less gain is less noise, but it's got more noise. So maybe there's something we can do to these 5,000s, track out where the noise is being generated, and fix it up, and then you have a really, kick butt detector. But yeah, definitely a lot more noise. Even though we've done frequency scans and everything, it's just noisy. So if you going along listening to that whoopity whoop whoopity whoop all day, you know, any one of those, chirpy sounds could be a target, and you got to ignore it because you know they're not targets. And when you actually hear a real target, you're going to say, "Oh, it's one of those." So that's why you got to keep your detectors very quiet. You've got to be quiet. You can't have chirpiness in the detectors. You know, I've been doing this since 1980, and I've had just about every detector. Well, I think I've had every Minelab detector. Um, well, even if they're customers' detectors, I've had to go out and test them, so I've actually used them. So even going back to the Gold Seekers 15,000, which was a tin box, very early. I think that was before Minelab was Minelab. Uh, like I say, it's a long time ago, and used all Whites, Garretts, Bounty Hunters, Tesoros, um, you know, Garrett. Everything from Garrett. I tell you, every green box they ever made. Um, you know, some of the dual detectors, dual purpose, coin and gold. Um, Whites ones. What is there? There's explorers. There's all sorts. I'm not going to go for them all because there's probably about 100 of them or so. But even the new 6,000, the 6,000 is interesting. I got videos on that. It did go completely bonkers on me at one stage, and what I found though, it is relatively sensitive. It's good for very, very, very small gold. I'd rather use the 6,000 than the 2,300. Um, you know, like I think we've got videos going back probably 10, 15 videos back where I had a modified 4,500 outperforming the SDC 2,300 on small gold very easily with a bigger coil. You go back and check that out. You know, we've had the 7000s. We've done upgrades on the 7000s, done side by side testing. The upgraded 7000's far quieter and works a hell of a lot better. That's probably 10 or 12 videos back. Yeah, these are a heap of things that we've done over the years. So yeah. So yeah, there you go. That's the chirpiness out of the fives. The fives are chirpy. They got less gain, and I'm going on a mission. I'm going to find out what the problem is because it shouldn't be there. It's some sort of intermod mixing or something. There's something not quite right, and it's going to. Well, look at all the parts on these boards, right? We're going to look at all the parts there, and I'm going to start, measuring and trying to work out exactly what's going on. It could even be in the software. It might be differences in timing. Um, basically, what do we want to call it? Like, it's not actually. Well, I was having to talk to a fellow um, last night, and we actually come to the conclusion. People say, "What frequency does a PI run on?" It doesn't. I mean, it does, but it doesn't because it has different square waves driven out of the transmitter at different time intervals and different widths. So it's not a repetitious common frequency. You can't say, oh, it runs at 18 kilohertz because it doesn't. Because the big pulses are slower and then you've got small ones that are faster and you've got different gaps between those pulses. So there's no actual repetition that you can say, oh, it runs at that because it doesn't. So we came up and we called it frame rate. Okay, so what frame rate? So basically, how many frames of ground, big pulse and three little pulses or whatever timing you're in happen in a second. So that's how we're going to look at it from now. We're going to call it frame rate because technically that's what it is. It's not a frequency. So you know you can say, oh, well, that one's 160 microseconds and those are 35 microseconds, and no, because that means they're different frequencies. So that's what it is. But I'm going to work on this. I'm going to find out what it is. If you've got a 5000, I think we can greatly improve the performance of the 5000. We can definitely improve the performance of the 4500s. Actually, we improve everything from SD2000 onwards. If you're ripping out components that are, near 30 years old technology for the 2000, 100% is going to work better. It's just obvious. It's like, you know, it's like swapping out vacuum tubes for transistors. It's a big difference. It really is. A lot of efficiencies to be gained. But even though the SD2000 is a damn good design, um, you know, but it has its power supply running all the time. For the +5, and it's switch mode, and it's getting into everything. So there's ways and means to do things to those detectors too. So that's enough waffle, and yeah, I hope these are educational for you guys who continue to use um, standard pulse induction detectors. Um, like I say, all you got to do is upgrade the componentry into better components, and it works better. Pretty simple. Anyway, catch us later.